Right, this talk using open source observability with Lambda. This talk isn't going to be going into Lambda that much because, well, it's, how do I put it as politely? It's been covered ridiculously well in the last 4 years, and there's an entire slew of information on YouTube for you to learn from. So if you wish to learn more about Lambda, there's a lot out there. Open source software for observability is kind of a bit newer. So I am Mike Elsmore. I am developer advocate at Logs.io. If you wish to send me help requests, requests for information, anything, you can get me on my email address, which is on screen right now, and my Twitter handle. Feel free to just catch me on my own time, and I will try and help, even if it's not observability related, even though it really should be. But if it's not, I'm okay with that. So what's the problem here? Well, I am a horrible developer, and I build things in Node.js. I build really, really small pieces of horrible code and ship them to the masses so that people will use them. Yes, I'm sorry. You're being told something by a mediocre Node.js developer. But what this actually really means in this world is I am actually shipping metric tons of units of 400-line pieces of code. So when I write one Wii module package or otherwise, it's being shipped everywhere at scale with hundreds of people consuming it and, well, or thousands or millions if I'm really, really lucky, but I really hope not. And something is going to go horribly, horribly wrong. And in our case specifically, we're just going to watch the counter as, say, we have 100 Lambdas out there. We then have them distributed across every data center, well, not data center, every region within AWS. So we then go from 100 to over 1,000 of these compute units. And those compute units also auto-scale. So it's not just 100 copies of code in a bunch of places making over 1,000 units. We then have thousands of those units being spun up at any one time depending on the usage at the edge. And that just means that we officially have Lambdas everywhere. Wherever you see Lambda, you just so much. If you've seen the lovely microservice network graph from Netflix, that is how my brain now thinks of JavaScript code being shipped in Lambdas, because there's just so damn much. So when it comes to actually operating and running these pieces of code, we're all used to using console.log and just dumping stuff out and reading it and working out what we're doing with it. Easy enough. And that's pretty much the same across all languages, that we all have console, print, any way to send information out to std out or std error if we so desire. But we don't always follow great conventions, and we also don't know what to do with that information about those compute units in general. So what's the next step for this? Well, observability. If you've never heard of observability, it's this. It is built of 3 core principles, and these are technologies that are either bloody ancient, quite commonly used, or new and shiny. Well, new-ish and shiny. So logs, we're all aware of logs. We've all spent hours tracing through Apache logs, Nginx logs, random streams of logs on any Windows machine to work out why things went kaput. We're just used to it. And then there is metrics, which is the information around a compute unit, its usage and pattern. And then there are traces. More commonly known as distributed traces. This is a way of seeing where the problem is in a system that is connected. So in a monolith, you go, the problem is the monolith. It's somewhere in there. When you have a lot of compute units, traces gives you more finite control of finding out where in your linked bunch of services the problem is. So most of you are probably thinking, nuts to this, don't need it. It's overkill. Why bother? Well, it's not going to be easy. I'm sorry. You eventually are going to have something explode, and you are going to have to implement these things. If you're running any system at any scale, even if that's just a few hundred people a day, but your resources are really precious and you need to make sure that you have uptime because it's important. All this information is going to be needed. So let's start with all the different parts of it in a logical order, shall we? So we'll start with what I consider easy mode because it's the one that any developer, be it a hobbyist or a professional, has used day in, day out and has worked out what they're doing. So what are they in reality? They are just immutable data points. Usually, and hopefully, to make things a lot easier, they contain their timestamp and discrete data for the event. So that could be a custom event or something that a application that you are leveraging is throwing up. Simple. You can send these in plain text. So we've all done this in my JS world. Console.log hello or harrow or anything to just find out where my code is dying in execution. I scatter that hello 1, hello 2, hello 3. Yes, I have done that. I'm pretty sure everybody else has done that as well. We're all used to doing that. It's dumping plain text out to see where things break. Then there's structured data. This is dropping, JSON objects, something that can be interpreted by machines later and actually reused. Structured data doesn't necessarily need to be JSON. It can be just in a structured format or in a machine readable format. Apache logs being a great example. Technically plain text, but technically structured. Easy to consume. Then there is binary. Not a lot of systems use it, or at least I have not used many systems that use it, but it's primarily big constructed binaries that dump out something like a protobuf? Yeah, protobuf with the information in there. To then consume later on and usually reconstruct into structured data that can then be analyzed. I'm assuming everybody is happy with what I've said and doesn't want to correct me so far. Okay, cool. I'm not getting anyone going, no, you're wrong. Okay, so the best open source tools for this, in my opinion, is the ELK stack, built of Elasticsearch, Logstash, and Kibana. Elasticsearch being the storage medium, Logstash being the processing medium, i.e. to grab, sample, and process any log format into a structure that can be stored in Elasticsearch. And Kibana is the visualization tooling for being able to interpret, discover, and process that information as a human. So it's pretty powerful, and it is open source. It's not open source in the sense of governed by a large body like the Linux Foundation. It is controlled and managed by a company called Elastic, but they do it quite openly under the Apache 2.0 license. There's also, in recent years, they have implemented a system called beats. Now, beats are smaller units which help with the processing of information. So there is file beat, heartbeat, metric beat. These focus on gathering the information for their specific field rather than having one general processor that you have to throw the information at. Just simplifies machining. Think of it more like a specialist agent that you would install on a machine. And in this case, for logs, we are going to be thinking primarily about FileBeat because it's the one that processes log files. Ta-da! However, in reality, in Lambda, that's not something we worry about. So, system metrics. This is what I call the intermediate mode because it's the bit that people normally don't think about until something has gone horribly wrong and is exploding, which is a horrible fact, but it's true. People don't think about this when they're gathering their system together. So, what is it normally? Once again, immutable data. Why the hell would you store information like this in a mutable state? No point. Usually consisting of its name, a data point, and its timestamp. So if you're using the module beat, the metric beat for the Elastic Stack, this one has the default system module, which can then just provide the default information from the system. That would be CPU, memory, disk I/O usage, network for the host machine that's installed on. So it can be all these predefined, but you can also define custom behaviors for them. So metrics always allow for custom behaviors. A lot of places I've seen it being used are using user behavior so they can track when users are doing specific things and how that is affecting the metric data from the system, e.g., if somebody is scrolling like a boss and loading a whole bunch of images, you can then see the CPU usage of any CDN devices that are, custom resizing on the fly. So that's a use case for it. The common and tools used for metrics and metric analysis is Grafana and Prometheus. Grafana is primarily a UI and investigation tool. It plugs into Prometheus for use with that stack or the ELK stack. We'll show you the dashboard so you can see the sort of thing you can pull out of that in a little while. And Prometheus is, I would like to say, the new kid on the block, which is the new hotness. It's not even that new, but it is becoming the biggest name in open source metric software. So using the PromQL process, it allows for long-term storage in things like M3DB, as well as on its internal engine for very quickly being able to see as the system stands metric information. It also has plugins for things like, it has the ability to be used with things like Graphite, Grafana, etc., which makes it a very, very useful tool. We're good so far with metrics. I'm looking for some nods. There we go. I'm seeing one nod. I'm moving on. Next up, tracing, distributed tracing. This is what I call hard mode, and that's only because it's the newest one in this suite of tools, and a lot of the software is still relatively new. So this is end-to-end flow of an application. Think of it, if you're a browser dev, you open up the network tab, you can see the flow of all the network requests and how they impact on each other. This is the same sort of thing. However, this can be any part of your system. A trace is normally built of spans. Your span would be a period of time you define inside of your system, be that passing through a function, be it passing through a class or a set of functions, or just passing through, if it's, say, a small microservice, the microservice in entirety. But you build those traces together so that you have one microservice passing to another, to another, to another, and these spans would go across all of them. The reason that's important is in microservices where you have things trying to run autonomously, either dying and rebuilding themselves or just scaling up, you don't necessarily know which part of your component of your system or any component is struggling at any one time. So tracing makes it very, very easy to find out where you've got compound issues. So say you have a service which is a non-scaled Docker image that's in between stuff doing some video processing or something. If that's backed up with a queue, you can see where the response time for that is increasing and causing a issue across the rest of it. You think of it similar to old school profiling tools for programming of a bygone age. So using things like Xdebug and Xprofile with PHP and JavaScript. So just see where the problem in a monolith is. Best open source tools for this. There's actually 3 of them, but I don't have any experience with a third, so I drop it off. I just mention it by name. So there's Jaeger. Jaeger is a project that was spun out of Uber, and they still use it internally. They just have their own fork of it that they build and maintain. They also have are also the people who produced M3DB from Prometheus. So you know what? They spent a lot of time investing in operational tooling like this. We should all take advantage of it. There's also Zipkin, which, if I remember correctly, is spun out of Expedia. Please feel free to correct me if somebody is more knowledgeable with Zipkin. I have used it, but never really played with it because we use Jaeger at work. So that's what I use. And the third one that I try not to mention because I know barely anything about it, but it is part of this trifecta of big tools, is skywalking. Now, these all follow tracing. They all do traces and spans and produce a map and a profile of the system, but they do it in slightly different ways. So we will skip over that and just leave you with these are the best tools for the job. In the bits of stuff I'm going to show off in a moment. I'm not going to be covering tracing because trying to show off the code for implementation, sampling, and consuming the information that comes out of Jaeger and tracing is a whole 30-minute talk upon itself. So I'm going to skip that bit because I'm pretty sure the organizers will kill me if my talk turns from roughly 25 to 30 minutes to an hour and a half on its own. So this is where we get into the dangerous territory, the demo time. So I, over the weekend, built a horrible, because I realized I actually needed a demo to show this off and actually make my point. Horrible Lambda stack using the serverless framework. If you're not aware of the serverless framework, it is a relatively language agnostic framework for deploying to its primary is AWS, but it also deploys to Azure and all sorts of stuff. It's just a way of simplifying the actual structure and building multiple functions inside the same stack so you can have one service built of many functions. So we have two handlers in this case, one which is my hello handler, which is on a timer grabbing the latest trending GIFs from Giphy, because why would I do a tech talk without either cats or GIFs? And then the other one, which is a post-process. And this is just simply to produce more data. I make it grab the image and create a single slide thumbnail of it, just because it produces more data. It also means if the format of the GIF coming in from the Giphy API is something unexpected and unable to be easily processed, this throws some errors. So I may actually have some error information today to show you in the last 3 hours from a trending GIF that is of, said, a WebP format, which it doesn't like processing. And then just to make the point, I'm also going to be showing some other stuff on how it actually gathers all the information and simplifies it, because why wouldn't I? And the biggest part of this serverless file is just the CloudFormation to stand up 2 bloody Docker containers. If anybody says they like CloudFormation, I need them to deeply explain to me why it doesn't hurt them in every way that they do. Because I'm sorry, when it takes 110 lines to stand up 2 Docker containers, somebody has done something deeply wrong in life. And that was me taking all the shortcuts I possibly could, like using full access policies rather than actually taking proper security. So I'm also very carefully have hidden all my credentials in SSM so I don't accidentally expose them to you and get told off by my boss. In here, we actually have the Jaeger container because I want to just have it just in case I have time, and the Docker container. Now, with the metrics information, I'm going to start on metrics rather than Kibana and the logs, just because we're there and I'm looking at it right now. This is literally just a Docker container running metric beat inside of itself, and we just tell it to, using the custom module we have, connect to CloudWatch and gather the metric information that is dumped into CloudWatch. We give it the 2 namespaces we can follow, so AWS Lambda and S3, and it just harvests the CloudWatch APIs and throws this through 2 logs.io for us to consume in Grafana. And that's really, really simple like that. And just to make life easier, just to show you how actually simple this can be. And you can do this with the open source. There's a bunch of open source tools for this as well. It's not just the stuff we've built proprietary for us, but literally a lot of people have spent time just simplifying it and going, oh, this is a log one, not the metrics. Metrics, AWS. Nope. Yeah, it is AWS. There we go. Yeah, Lambda. And it is that simple as installing region, drop the Docker container, feed it some information, and then suddenly you get data. Open source software is great because it means that people have done a lot of the hard work for you and you can be thankful for it. So here we go. We drop in and let's see if my Lambdas have been working for 2 days without crying. Based upon the spikes here, they are running every 5 minutes as intended. Excellent. Let's go over to the pre-built AWS Lambda dashboard. Way! we can see information, and Grafana already provides a bunch of pre-built, well, they aren't pre-built, but when you define the dashboard, you can provide a bunch of filters. So I just want to concentrate on US1, which is where I have dumped this Lambda. Yeah, we go. We can now see minimum, maximum duration of runtime. So we can see if we're running up to the 5 minute, is it 5 or 6 minute default clock on a Lambda. And we can see the, oh, for the love of Hades, for once, it's not giving me any errors. It was giving me plenty yesterday. I'm sorry. In the last 3 hours, I've managed to build code that doesn't break. That is, I am sorry, everybody. Everybody, I needed failures. But we have all the information from Lambdas, the number of executions per period. Yeah. And then the success rate. Once again, I haven't caused any errors. Otherwise, the graphs would be more spiky and stuff. If I introduce this stuff, if I reintroduce the stuff which has got my other experiments in Europe, there we go. There's some more errors. And oh no, that's not erroring either. For the love of God, I need to build demos which break. Yeah, but we can actually see difference in actual execution pipelines and timelines. Cool. Metrics. It's easy. Yay. We can also build a whole bunch of extra graphs yourself. This is just the default one. I hate trying to design dashboards that other people can consume and make sense of. Right. So back to the easy mode now that we've done metrics. Let's go with logs. So in the case of logs on AWS, they are really, really, really simple. We have, please tell me I remembered to sign in earlier. Oh, okay. There we go. Sign back in. They have this wonderful thing of only dumping out the STD and SD error, but then it interprets it all in a simple stream of information anyway. So to say, there we go, and we just get it dumped out to CloudWatch. Now, that's fine. This is great when we're building it and debugging it. We actually have all the information we want here. But what about if you want to do something more structured with it, actually interpret them, or even only send the critical logs to to somewhere that you can then actually process them? Well, this is how we do it. We would instantiate, in my case, instead of just dumping out the console log, I would use a library that enforces a format that can be reconstructed and processed. Personally, in JavaScript, I like using Winston. It produces a JSON object format, as you saw here, which makes it very clear and easy to process and reuse. You can then throw it in the message object. It can be thrown in nested object or strings, depending on how you feel about it. We're also configuring this so that the console is receiving all of the information. Anything sent to CloudWatch is being a debug level or above is being sent there, and only information that is of the info level is being sent to logs.io. And in our application, we just have a whole bunch of points where we're throwing data, and as I was hoping for, some errors, because errors. Surprisingly, didn't have any. But if we go back here, we will see that we are receiving all the information. So if we click type, we can see the Node.js errors, which are the ones that we are sending directly to logs.io, well, in this case, Elk, via the Winston library. And it's just simply thrown out. If you were to do this with open source Elastic, you can just use the Winston Elastic plugin to do the exact same thing. And it will just come out in exactly the same format. Well, hey, quite simple. And these are just the info and the any error statements would be in here. However, you saw that I had a whole bunch of extra logs, like all of them, like even all the rando debug statements. That's because I have been filtering all of the logs, all of the logs from CloudWatch to Kibana for this purpose of this demo. It turns out the best way to get information out of AWS CloudWatch is to install another Lambda, which fetches them and bulk processes them out for you. I know it's insane. To get information about Lambdas, you need to build and deploy another Lambda. It's not like they could just give you a simple streaming endpoint for this stuff because they don't want you to leave the ecosystem. So I essentially did this on Monday or Tuesday? Monday, to get this all stood up. And it is just a simple Python Lambda. If you're actually interested in looking in the code yourself, you can just go over to GitHub and have a look at it yourself. There we go. That's the repo. And you can just dissect it. I'm using the Python 3 version. All it does there is deploys it into an S3 bucket, executes it, and then this just attaches to, and if I go back, nope, don't do that. Functions. If I go, where are you, log shipper? We just manually configure an event trigger to list off the log, and it's then just capturing everything on a minute timer that goes into a log group and throws it over to logs.io for us to consume. Wonderful. That's essentially it. So, and there is a whole bunch of open source examples on how to do that as well. So you can easily send this into ELK if you so want. And that's pretty much it for just how simple and easy it is to get information out of Lambda in a format you can then construct and reuse. If we so desired, we could then start building queries using the available messages. So if we wanted, say, let's go with all the information that's been sent over by CloudWatch, we can then tell it we only want to be looking at the debug statements. You should be behaving right now. I wonder why it was not playing nice today. Okay, but yeah, we can then, and if we so desired, we could actually graph that. If there happened to be a relevant piece of information, I could then build a graph on. Turns out I didn't send any numeric information in there to build a decent graph on. That's a hindsight moment I should really take on my demo for next time. So yeah, really simple way of grabbing information and throwing it over. If anybody wants my horrible source code, feel free to ask, but I advise against it. However, I'll happily talk through how to do it properly at any time. So there is only one thing else that I want to really point out before the end of this, and that is OpenTelemetry. Now, OpenTelemetry is a specification for gathering log data, metric data, and tracing data and outputting it to wherever you want. This is an open source specification that was formed from joining the Open Census and Open Tracing projects. The idea being it will be one specification across multiple libraries and multiple languages to simplify the gathering of information and making it more democratic in the way that we don't need to care about the vendors because it's just a specification. It can be sent over to logs.io, it can be sent over to the open source, doesn't matter. It's a simple and complete specification for it. I will, however, admit the logs specification hasn't been completed and will not be available as part of its GA. It's currently in its beta phase and does have, and I'm not kidding, libraries for days. The specification is completely open, so you can have a look at it yourself. And then they have the instrumentation, libraries on every primary language, and I think they even have a Haskell set. So if you want to abuse yourself, you can do it in Haskell. But it's got the specification for logging, for metrics, for traces, the combined process, the collectors, and the specification for sampling. So you know how much information you want to be sent through any flow point. And I think that's really important because we as developers and operators don't want to have to deal with people above us going, oh, we can't afford to have X. We want to swap it out for something cheaper and have to retool everything. We have a simple, if we have a single specification that we can then use to then just change the vendor underneath with their exporter, hunky-dory, I'm all good with that. So yeah, that's me. Ta-da!